Hello everyone. Hi Shreya. Hi Debabrata. Hello Meghna. Very good evening to all of you. I welcome you all to the JEE Bytes session today. Today we'll be studying about surface chemistry and general principles and processes of isolation of elements. Okay, that we'll be discussing today. We'll be discussing the important topics from which the questions are generally asked from this chapter, and also the questions which were previously asked based on this. Okay. Hello, Arushi. Very good evening to you also. All right. So let's begin with the session on surface chemistry and metallurgy. All right. So starting with our first question, we have this question on Tyndall effect. So by the first word itself, you can understand that it's on colloids. Right. So whenever you are studying about the surface chemistry, you need to know there are certain topics among which the questions are very frequently asked. And those important topics are, first, let me tell you about that. The important topics are adsorption. In adsorption, you need to study about the types of adsorption, the mechanism of adsorption, the basics about the adsorption. Okay. And obviously the classification and the properties like physisorption and chemisorption. What is the basic difference between both of them? What are the factors that affect adsorption? All of these comes in the mechanism of the adsorption. All right. Then the next important thing in this chapter of surface chemistry is catalysis. Catalysis is also an important topic here, which you need to study in detail. Then another important topic is we have colloids and emulsion. Emulsion is also a type of colloid. I hope all of you know that. The types, the properties, different types of colloids, what are their examples, their properties also, of course. These are the important topics of surface chemistry. Okay, so let's begin with the topics here. Hello, everyone. All right. So those of you who have entered just now, very warm welcome to all of you also. All right, so let's start with the questions which were previously asked on this. Then we have the question, the Tyndall effect is observed only when following conditions are satisfied. The diameter of the dispersed particles is much smaller than the wavelength of the light used. Second is, the diameter of the dispersed particle is not much smaller than the wavelength of the light used. The refractive indices of the dispersed phase and dispersion medium are almost similar in magnitude. And the fourth point is, the refractive indices of dispersed phase and dispersion medium differ greatly in magnitude. All right, so among all of these, what do you think are the necessary conditions that should be satisfied for the Tyndall effect? Tyndall effect occurs only through colloids, right? And in some cases by suspensions also. So basic reason why the Tyndall effect occurs. First of all, what is Tyndall effect? The scattering of light by the colloidal particles. And the conditions that are necessary here are that the diameter of the dispersed particle shouldn't be much smaller than the wavelength of the light used. Okay, there are three phenomena that occur while the scattering of light because of Tyndall effect. That are, first of all, there is reflection, then there is refraction, and then dispersion or diffraction. Okay, these three phenomena occur together, which results in the scattering. Okay, the first option that is given over here, the diameter of the dispersed particles is much smaller, is wrong. It shouldn't be much smaller. It should be slightly, it shouldn't be directly equal also, but it should not be much smaller than the wavelength of the light used. There should be little difference between the wavelength and the diameter of the dispersed particle. The Tyndall effect are necessarily shown by the colloidal particles because of their size, because of the size of the colloidal particles that they have. That is why they're not shown by the very small particles which are present in the solution case, right? Is chemistry in NCRT enough for NEET aims? Please tell ma'am. Aditya, your question. So NCRT is very, very important for your NEET and aims, but you also need to practice a lot of questions in order to clear that. Okay, so that was your query that I answered now. And get back to the topic. So here, the diameter is not much smaller than the wavelength of the light, which is the necessary condition. Next, we see the refractive indices of the dispersed phase and dispersion medium are almost similar in magnitude. So is it right or is it wrong? Yes. They shouldn't be much similar in magnitude. Okay, if they are almost similar in magnitude, and then the diffraction is not going to take place. So there should be difference. They should differ greatly in magnitude. The option 2 and option 4 are correct. So the answer here would be 2 and 4, that is option B. Okay, this was asked in mains 2017 and I can directly see many of you have answered it correctly. So that's good. And you all know that there can be like multiple choice questions also that could be asked in the exam. Okay, so be prepared for that also. Next question we have is for a linear plot of log x by m versus log p in a Freundlich adsorption isotherm, which of the following statements is correct? K and n are constants here. So when I was telling you that adsorption is a very important topic, there is a subtopic in adsorption, that is adsorption isotherm, which is very, very important. Okay. So here, it was also asked in mains 2016. You should know what is the basic formula which is used in the Freundlich adsorption isotherm. The formula here is x by m is equal to k p to the power of n. All right, where x by m suggests how much amount of the substance is adsorbed. Okay, k and n are constants and p is the pressure. All right, so when you take log both these sides, it will become log x by m is equal to log k plus n log p. Right? Log x by m is equal to log k plus n log p. Now, in the question you are written that there is a linear plot of log x by m versus log p. Fine. So that's this equation is equating to the plot here, and which you can equate to y is equal to mx plus c. Right? Oh, I'm sorry. I wrote a little bit wrong. It's not n, it would be 1 by n, right? So it will be 1 by n log p. So y is equal to mx plus c, where y here is what? Log x by m. And then k is what here? Slope is what here? What will be slope? That is m. Slope will be equal to 1 by n. And what is x? X is log p. Right? You can equate it to the similar equation, right? So when you look into the options, you can see that the first option is wrong. The intercept here is log k. Only 1 by n appears as a slope, and that is absolutely right. Log 1 by n appears as the intercept. No. Log 1 by n is not the intercept. Log k is the intercept here. Both k and 1 by n appear in the slope term. So that is also wrong. So the answer here would be B only, right? So here the answer is B. I hope you understood this question. This was also an important question asked in mains 2016, which is directly based on your basic concept regarding the Freundlich adsorption isotherm, right? The next question we have here was asked in advanced 2017. The question is, the correct statement about surface properties is or are. Option A is the critical temperatures of ethane and nitrogen are 563 Kelvin and 126 Kelvin respectively. The adsorption of ethane will be more than that of nitrogen of same amount of activated charcoal at a given temperature. All right. So you are said that critical temperature is given to you. You are said that the adsorption of ethane will be more than that of nitrogen. Is it true or not? What do you think, people? How does adsorption depends on the critical temperature? So for that, you need to know what is critical temperature first. Okay. Critical temperature is the temperature above which the gas, the minimum temperature above which the gas can get liquefied. Okay. Above which you can liquefy a particular gas. So higher is the critical temperature. Higher is the value of critical temperature. Easily liquefiable the gas is. Okay, it can be easily liquefied. All right, and lower is the value of critical temperature. It's difficult to liquefy the gas. So more easily you can liquefy the gas, more easily it can be adsorbed also. All right, so here you can clearly see that the critical temperature of ethane is higher, that is 563 Kelvin. So that means it's easily liquefiable, and that also suggests that the adsorption of ethane will be more than that of nitrogen of same amount of on the same amount of activated charcoal at a given temperature. So A is absolutely right. B is given that the cloud is an emulsion type of colloid in which liquid is dispersed phase and gas is dispersion medium. Is it true? Colloid, we have the dispersed phase as what? Liquid. And what is a dispersion medium? Dispersion medium is gas. Right. So this is half correct. That is, liquid is a dispersed phase and gas is a dispersion medium. But it's written that cloud is an emulsion type of colloid, which is absolutely wrong because emulsion is liquid and liquid. Here we have liquid and gas. So this is which type of colloid? It is basically aerosol. So you can say it as an aerosol, but you cannot say it as an emulsion. So this statement would be wrong. Right. Then C is adsorption is accompanied by decrease in enthalpy and decrease in entropy of the system. So when we talk about adsorption, as I told you, its mechanism is very important. You need to know the basic information about adsorption first. So in adsorption is an exothermic process. Okay, delta H always is negative in this case. It's an exothermic process. All right. There is decrease in the energy of the adsorbent during the adsorption. Fine. And when we talk about delta S in this case, that is positive or negative? That is decrease. There is decrease in entropy or increase in entropy. You know that during adsorption, any substance is getting adsorbed on a particular surface, on the surface of adsorbent. All right. So what is basically happening here? The randomness is decreasing, right? The randomness of the substance is decreasing. So delta S is going to be negative in this case. Now we know that for a spontaneous process, delta G is equal to negative. Delta G needs to be negative, and delta G is nothing but delta H minus T delta S. So if delta H is negative, delta S is negative, for delta G to be negative, we need delta H also to be negative, right? Because this term will become positive if delta S is negative. But if we want the entire term to be negative, we want this delta H to be negative. Okay, so here it's again exothermic process. So here you can see the adsorption is accompanied by decrease in enthalpy. That's absolutely right. And decrease in entropy of the system. That is also right. So option C is also correct. D is Brownian motion of colloidal particles does not depend on the size of particles, but depends on viscosity of the solution. Exothermic, Ajay, it means that the energy is released during a particular reaction. All right. Then Brownian motion does not depend on the size of the particle, but depends on the viscosity. This statement is absolutely wrong because Brownian motion depends on the size of the particle also as well as on the viscosity. What it doesn't depend on is the nature of the particle. All right. So this statement again is wrong. So the correct statements here are A and C. This was asked in advanced 2017. It was multiple correct questions. So It's also an important question. If you know all the basic thing and the theory about this chapter, you can easily answer this question. All right. Okay, let's move on to the next question. Which one of the following ores is best concentrated by froth flotation process? So you need to know what is froth flotation process and for which type of ores is this used. Froth flotation process is a type of concentration process and it is used for the concentration of sulfide ores. Okay, so this first of all you need to know. Secondly, you need to know the formulas of all of these and in which of them sulfide is present basically. Okay, so siderite, galena, malachite and magnetite. What do you think is the answer? Absolutely, Shalini. The answer is galena here because it is PBS. Rest of them are not sulfide ores. Galena is. So the answer here would be B. You need to know the formulas of all the ores that are written in your specifically in your NCERT. For this particular chapter, NCERT is very, very good. Okay. Then the next question we have here is that copper is purified by electronic refining of blister copper. The correct statement about this process is which of them? During the metallurgy process of copper, first of all, blister copper is achieved. Okay, but it is the impure form of copper. We need to purify it further. For refining this, we use electrolysis. Okay, so the questions that are the options which are given over here, impure copper strip is used as cathode. Acidified aqueous CuSO4 is used as electrolyte. Pure copper deposits at cathode and impurities settle at anode mud. Okay, so here basically only what you need to know is what is electrolysis, electrolytic refining. Okay, what happens in that case? Always the anode in this electrolysis is taken as the impure metal. Okay, so impure copper will be anode, not cathode. And cathode is what? Cathode is the pure electrode, pure copper. All right. So, and obviously, we are whenever electrolysis is done, we are dipping both the electrodes in a common electrolyte. And the electrolyte taken here is CuSO4. Okay, so this statement is absolutely right. A is wrong because impure copper strip is taken as anode. C, pure copper deposit at cathode. That is also correct because while the electrolysis is occurring, on anode we are having this oxidation occurring. Okay, copper is getting deposited on the cathode, pure copper, and the impure copper is getting settled below the anode as anode mud. So D is also correct, C is also correct, and B is also correct. Three options are correct: B, C, and D. Okay, A is absolutely wrong here. All right, so the basic process of metallurgy, in case of the metallurgy chapter, the basic process of metallurgy, first of all, we are doing concentration of ore, then oxidation, then reduction, and then refining. That basic process you need to know. And for certain metals, specifically, you need to know the entire process. What is the specific process for oxidation, reduction, concentration, and everything carried out, and the different processes of refining which could be possible for different metals, that you need to know in this chapter. And of course, the names of the ores and for which metal, which type of metal is extracted from which particular ore, that you need to know very well. Okay, so this is also important chapter. And basically, surface chemistry as well as your metallurgy, both of them are scoring chapter. If you read them very thoroughly from NCERT and practice a lot of questions based on this, because most of them are theoretical questions only, so you can be pro in this particular chapters. All right, so that's what is required here, a lot of practice. And that's all for today, people. And I hope you all have understood everything. So thank you so much for listening to me carefully in this class. Bye-bye, everyone. Goodbye.